Hello students, my name is Harish and today I am going to explain you the topic electric current and circuit. This topic is from the chapter electricity. Let us start. We all are aware that an atom has a positive charged nucleus in the center and negative charged electrons revolving around it. And the electron present in the outermost shell is known as valence electron. Now, in a metal conductor, these valence electrons are free to move, and that is what constitutes an electric current. So basically, if the electric charge means our electron has a negative charge, so if the electric charge flows through conductor, we can say that there is an electric current in the conductor. Is that clear? Now, if this electric current flows a continuous and closed path, then it is known as an electric circuit. That means the current is flowing inside it, and the current I is flowing inside it in a closed path. Okay, it is flowing in the clockwise direction in a closed path. So this is what is known as electric circuit. Okay, now electric current is expressed by the amount of charge flowing through a particular area in unit time. In other words, it is the rate of flow of electric charges. We will understand this definition in the upcoming slides. Okay, let's move on. Now, electric current was considered to be the flow of positive charges, and the direction of flow of positive charges was taken to be the direction of electric current. Now, when the electric current theory was proposed, at that time electrons were not discovered. So they considered it to be in the direction of positive charge. But now we all know the electron exists. And we all know that due to the movement of the valence electron, there's a current. That is why conventionally in an electric circuit, the direction of electric current is taken as opposite to the direction of flow of electrons. So basically, if this is the direction of current, that means if the current is flowing in clockwise direction, then the electrons are moving in anti-clockwise direction. Okay. Now, what is current and how do you quantify this current? Now, if a net charge Q flows across any cross section of a conductor in time t, the current I through the cross section is I is equal to Q by T. Q divided by T. What is Q? Q is a net charge, and what is T? T is the time. Okay, so if you take a conductor and if you cut it and if you see a particular cross section, any cross section you take, then what is the net charge that has flown through the cross section in the given time? If you divide these two, you will get the current in the conductor. Okay, now Q, the net charge. The SI unit of electric charge is coulomb. And what is coulomb? Coulomb is something which is equivalent to the charge contained in nearly 6 into 10 to the power 18 electrons. Okay, and what is the charge of electron? The electron has a negative charge of 1.6 into 10 to the power minus 19 coulomb. Okay, so basically the current I flowing through any conductor is the net charge flowing through any particular cross section upon the time, and we get current. Now, what is the SI unit of current? The current I is written in the terms of ampere. Okay, the electric current is expressed by unit called ampere. This was named after the French scientist André Marie Ampere. Okay, now how do you define this ampere? 1 ampere is constituted by the flow of 1 coulomb of charge per second. Now, if you recall, I said that the current I is equal to the net charge flown upon time, right? So here they're saying that the net charge flown is 1 coulomb and the time is 1 second. So if you divide these two, 1 coulomb upon 1 second, you get 1 ampere. So this is how you define 1 ampere. What is 1 ampere? 1 ampere is basically the flow of 1 coulomb of charge per second. Okay, so we get 1 ampere. 1 ampere is 1 coulomb upon 1 second. Now, sometimes the small quantities of current are not expressed in ampere. They are expressed in milliampere. And they are written like this: 1 mA. Small m, and capital A. This is 1 milliampere. And 1 milliampere is equal to 10 to the power negative 3. Okay, remember that. 1 milliampere is 10 to the power minus 3 ampere. So basically, this milli is 10 to the power minus 3. So when they say milliampere, 1 milliampere means 10 to the power minus 3 ampere. Okay. Similarly, it can also be represented in microampere. Microampere is represented as 1 small mu. Okay, that's not u, it's mu. 1 mu A, that is equivalent to the 10 to the power minus 6 ampere. Okay, so what is this? 1 mu. Mu, not our u. It is mu. So it's 1 mu A, that is 1 microampere is equal to 10 to the power minus 6 ampere. Now, what is an ammeter? Now, how do you think that when electric current is flowing inside a circuit, and how do you measure that circuit? That is why this ammeter helps us. Ammeter, it is an instrument that measures electric current in a circuit. Okay, so what is ammeter? Ammeter is a device which is used to measure electric current inside a circuit. And this instrument is always connected in series with the circuit. Okay, if you recall the diagram I shown you, see the battery, and there's a bulb, it is connected in series. See, they all are in series. That means if you cut open here, if you cut the circuit from here, and if you uh, pull these strings, you'll notice that they're all in a line. So they're all in a series. Okay, so the ammeter, what is ammeter? Ammeter is a device which helps us in measuring electric current. And it is always connected in series with the circuit. Okay, thank you.